Hi students, I welcome you all in the Let's Crack the Gate initiative by TEQIP Faculties, and this is my 13th lecture and probably this is my last lecture on CFJ and PDA. Okay, so in previous lecture we have already seen that some of the languages and we have identified whether that languages are context free languages or not. Parallelly, we have also seen that whether some of them languages are regular languages or not, and we have seen that whichever the language is regular language, all that languages are context free languages. Okay, so in this lecture we will solve some questions which is similar to GATE questions. uh, might be such type of questions will be asked in the coming GATEs. Okay, so let's start from the very first question. So this is the question. Consider the below mentioned grammar. Grammar is given with us. Just a second. Okay, and grammar is represented by G, and we know that grammar is having 4 tuples, that is VTPS. In this grammar, V is represented by N, and that contains the variable SBC, and T, that is the terminal, is represented by alphabet, and we are having ABD are the terminals, S is the start symbol, and P are the productions. So we can say that these are the productions. Okay, and we have to choose the correct option. So first option says that G is type 0 grammar, that is unrestricted grammar, and this grammar generates the recursive enumerable sets languages, that is recursive languages and recursive enumerable languages. And these languages we have discussed that these languages will be accepted by Turing machine. Similarly, type 1 grammar are context sensitive grammar, which generates the context sensitive languages and which will be accepted by linear bounded automata. So that is not a part of GATE study. Okay, and previously I have discussed about the type 2 grammar, that is the context free grammar. We have seen that context free grammar generates the context sensitive languages, and these context sensitive languages will be accepted by PDA. Okay, and last option says that none of these, none of the above, means 1 2 3 are not correct. So we will go through the grammar, and we know that always grammar is having a rule like that some non-terminal should produce either terminal or non-terminal. Okay, it is always be there, means compulsory. We can say that on the left side we need a combination of terminal and non-terminal, or only non-terminal. Okay, but here we can see that the production AB produces AC. Okay, AB produces AC means some non-terminals are producing some other non-terminals, but basically it violates the definition of the grammar. We can say that as terminals cannot derive anything. Terminals cannot derive anything. So this production is not valid in any type of grammar. So we can say that this is not a type 0, type 1 or type 2 grammar. So correct option is none of these. Okay, let's see the second one. So in this question the grammar is given, and grammar is having 3 production rules. So first production rule is S is producing small a, SB, capital A or epsilon. Second production AB, A is the non-terminal and B is the terminal. AB is producing BA. So this production is allowed in context sensitive grammar. So one of the production is context sensitive, belongs to the context sensitive grammar, then whole we can say that this is a context sensitive grammar. Okay, so we have to select the correct option. Okay, so the first option says that the language generated by grammar G is context sensitive language. Okay, let's see what this particularly grammar is generating. We will analyze that. Second option says that the language generated by grammar G is context free language. Okay, then third option says that the language generated by grammar G is DCFL, means which will for which for this language we can able to design a deterministic PDA. And in this, in second option, if that grammar is producing context free languages, means we are not able to design a deterministic PDA, we are able to design a non-deterministic PDA. We will analyze that and we will see. And finally, fourth option says that the language generated by grammar G is finite. Finite means that is the regular language. Any language which is finite, that will always be accepted by finite automata. So we can say that that is the regular language. Now we will take the productions. So first production is S is producing A, S, B, A. Okay, and we will try to get what actually this production is deriving. So S is producing A, S, B and A. Okay, suppose I will write like this. Then instead of S, if I will again write A, S, B and capital A. Okay, now instead of S, okay, I will write now epsilon, and instead of this A I will write C and this A. Instead of this A also I will write C and this A. And finally A is I am writing epsilon, and here also epsilon. Okay, so let's trace this, what actually the string we are getting from this. A, then B. Okay, just a second. So instead of tree method we will write derivation, because we have to check whether we can use this second production or not. So we will go by derivation method. Just a second, that will be easy to understand. Okay, so first production I'm using, so I will write production first, second and this is third. Okay, so first production is S is producing A, S, B, A, and I'm replacing leftmost symbol first. So again instead of S I'm using A, S is producing, again instead of this A I will write A, S, B, A. So A, S, sorry A, instead of this A again I will write A, S, B, A, and this B, A is as it is. Okay, now what we will do, instead of this, yes, I will now put epsilon, so it will become A, B, A, B, A. Okay, now instead of A we are having two choices, whether we can use uh, this production third, A produces CA. Okay, I will use that A, B, and instead of this I am using this is small c, again A and B, A. Again instead of this A again I will use number of times CA, but okay, I will now stop here only, and instead of A I have written epsilon, so this is become B and this is A. Here also I will use A, B, C, B. Here also I can use A produces CA, but here I am using that epsilon, so this is the final string I am getting. That final string is A, B, C, B. Okay, Similarly, if I will get another string, so yes produces AS BA is there. Okay, so instead of yes we will again use same way, that is instead of yes I will take same production, that is first one. So AS BA, okay, and that remaining BA as it is. Now instead of yes I will replace with epsilon, so this will become AAB, and instead of AB I will use BA. Okay, so this instead of this AB I am using BA, so this is become BAA. Now instead of this one A I will use CA. Okay, AABB CA, and this is final A. And now instead of this A and this A I will use this production, that is A produces epsilon. So AA, BB and C. Okay, so from these two strings we can assume that, okay, we have already as per the production second we have find out that the given grammar is not a context free grammar, it is a context sensitive grammar. Okay, but the language generated by the grammar is deterministic context free language. Why? Because the language is like this, it is having the A's equal to the number of B's. Okay, A's and B's are equal. You can find out any string, you will get number of A's equal to number of B's. And for this case, what we will do, we have we can design the PDA in such a way that whenever A occurred, we will push that A into the stack, and whenever B started occur, we will pop that particular A from the stack. And whenever C comes, we will just ignore that C, or we can say that just we will read that C, we will not do any operation in the stack. Okay, so this way the answer for this one is 3, that is C. We can say that this is the grammar generates the deterministic context free language, because we are able to design a deterministic PDA for this one. Let's see the another one. So this question says that we have given two sentences, that is statements. Statement S1 says that since every regular language is a CFL, okay, every regular language is a CFL, so we can use a PDA to recognize a regular language. Okay, and statement second says that a language generated by type 1 grammar, type 1 grammar means context sensitive grammar, cannot be CFL. Okay, and we have to identify which are the statements are true and which are the statements are false. Okay, and according to the option we have to choose the correct option. We know that PDA is nothing but finite automata plus memory, that is memory is fine, memory is also finite, that is stack. Okay, so in case of regular languages we don't require stack, we have already seen that. Okay, and PDA having a memory, and we can say that so PDA can also be used to recognize regular languages, because for this we don't require the stack, and without stack also we can use PDA. So we need to define transition in a such a way that instead of memory we will use directly finite automata, and we don't push anything into the stack. Okay, so this way we can say that the statement 1 is true. Okay, statement 1 is true. Now come to statement number second. It says that a language generated by type 1 grammar, that is context sensitive grammar, cannot be CFL. Okay, so we know that the context sensitive grammar, that is type 1 grammar, generates the context sensitive language, and like regular language accepted by PDA. Okay, so we can say that every CFL language is a CSL language, because every CFL language will be accepted by linear bounded automata. So a thing we can say that a context sensitive grammar can generate context free language, but reverse is not true. Okay, so like context sensitive, context free grammar generates the regular languages. Likewise, we can say that context sensitive grammar is also generating the context free languages. So statement 2 is also, statement 2 क्या ये means, statement 2 क्या given है, a language generated by type 1 grammar cannot be CFL, but it will be CFL. So statement 1 is false because it can be a type 1 grammar, can be a CFL. So the correct option for this one is second, that is S1 is true while S2 is false. Okay, so correct option is the second one. Let's see the next question. So question is like this: we have given a grammar, that is S is producing A is B and A or epsilon, and A is producing C A or epsilon. Okay, and they have also given the number of steps required to derive a string. Actually, string is given after converting grammar G into the Chomsky normal form. Okay, so when we can say that our particular grammar is in Chomsky normal form, suppose it will having the production like this: S is producing AB, or we can say that B is producing terminal. Okay, means a non-terminal should produce either two two non-terminals or one terminal. Then we can say that our grammar is in CNF form. And we know that derivation tree of strings is always a binary tree. So we can say that number of steps required to derive a string, particularly string is given like length, that is I'm considering here length of the string by this symbol. So number of steps required will be 2 into, because string is binary, so 2 into x minus 1, because for 1 that is the root. Okay, so that's why we are considering this formula. So the number of steps required to derive a string of length w when grammar is in form CNF form. Okay, CNF form में अगर grammar है और length of the string क्या है, x है, then we require these number of steps. So here length of x is nothing but the number of terminals we are having in the string. So in this we are having 2 A's, 3 C's and 2 B's, that is 7. So it will become 2 into 7 minus 1, that is 14 minus 1, that is 13. So the correct answer for this question is 13. We require 13 number of steps to derive the string AACCCBB after converting the grammar into the Chomsky normal form. Also you check for the suppose how many steps we need when the grammar is in GNF form. Okay, and comment that answer in the comment section. Use same grammar for that also. Okay, just you have to identify the how many number of steps required to convert this string, how many steps we required to derive a string. Okay, AA triple C double B after converting grammar into the Greyback normal form. Okay, Greyback normal. Okay, let's take another one. We have given a language. Language is like xy raised to power n. I am writing language here. Xy raised to n, xy raised to n. Okay, x where n is greater than or equal to 0. So same language will be written like this: xy raised to power n, xy raised to power n. So I can write xy raised to power 2n, and this x as it is, and when n is greater than or equal to 0. Okay, means n can be 0 also. If I will write some strings present in the language, that strings becomes minimum length string becomes x, because when n is equal to 0, this will become 0. When x is equal to n is equal to 1, it will become xy 2 times, and this x. Okay, this x is compulsory. Okay, likewise we will get infinite number of strings. So we have to choose a correct option. L1, whether the given language is CSL but not CFL. Okay, again L is CFL but not DCFL. Okay, third option says that L is DCFL but not regular, and finally they have given L is regular. First we will go for the regular, because if that is a regular, then it will be CFL, it will be CSL, and okay, DCFL also. So first point says that the language is not finite, so we cannot say directly okay, this is a regular language. If language is finite, then definitely we can say directly okay, this is a regular language. After that we will see whether we are getting the pattern or not. Okay, so we can say that we can see that we are getting the pattern, because 4 length string, after that we will get 8 length string, then 12 length string, 16 length string. Okay, so we are getting the pattern. So for this, if I will design a regular expression, so it will be like this: xy whole star, that is clean closure, and this is the x. Okay, means suppose I will put 0 here, then I will get the minimum length string as x, and if I will put instead of star as 1, then I will get xy x. If I will take star is equal to 2, then I will get xy x. Okay, so we can able to design a regular expression for this, means we can say that this is the regular language. Okay, so the option fourth is the correct one. L is a regular language, and when L is a regular language, that is definitely a context free language and context sensitive language also. Okay, let's see the another one. So next question is, we have given the languages L1 and L2, and we have to identify the correct option. So let's take language first. So we can say that a raised power n b raised power m is given. So I will write that language, just a second. So language becomes a raised power n b raised power m is given, and n is less than or equal to m. Okay, n is always less than or equal to m. Suppose L is equal to m, then we can say that a b b is possible, and when n is less than or equal to m, we can say that okay, suppose a, then b b is possible, because n is always okay, we can say that n is less than m. Okay, so if we will able to write the grammar, whenever n or m are equal, we can say that it will produce like this: a s b. Okay, or when we can say that n is less than m, so we will get like grammar a s b b. Okay, or when it is equal to 0, less is equal to 0, then we will get epsilon. Okay, so these are the things we will get, and we know that this particular things we can able to design a PDF for this. So we can say that this is the context free grammar. Whatever we have written, that is a context free grammar, and that generates the language L, the given language L1 generated by this written production. So we can say that particular this context free grammar. Okay, so we can say that the L1 is context free language, and similarly if you will see the language L2, that is not a context free language. Okay, because we are not able to design a either deterministic PDA or non-deterministic PDA, so that is a context sensitive language. So correct option for this question is, that is second. Okay, L1 is a context free language, but L2 is not a context free language. Okay, so these are the some questions regarding whatever we have seen, and if you have any query regarding any question, you can ask me in Telegram group. I will definitely reply on that. Okay, and one more topic is remaining, and that is not you means we can say that that is not having that much weightage, but for that I will cover a small video on that, and I will post whenever I will get the time. Okay, okay, now I hope you are getting interest, and I hope जो भी मैंने पढ़ाया है आप लोगों को अच्छे से समझ में आ गया होगा. Okay, if you have any query, then you can easily reach to me. I will definitely answer to you. Okay, so let's stop here, and all the best for you for the GATE 2022. I hope all of you get a good rank. Thank you so much.